The view of the starry night sky is simply overwhelming, and yet, we should not forget that all the countless formations that sparkle toward us do not represent the big picture. On the contrary, the truth is that from our earthly vantage point, we can see only an infinitesimal fraction of the universe. Consequently, we are not able to describe the exact shape and extent of the cosmos. But in the same breath, a fundamental question arises: what wondrous things lie beyond our optical range of vision? And is it even possible to discover them? Well, apparently it is. Some data literally scream that a full-grown colossus is lurking out there, its arm already stretched out toward the structures of our world. Why our earthly view of the stars is not really suitable for grasping the cosmos in its entirety becomes clear when we realize that the universe has put natural blinkers on us. The part we can see from Earth is appropriately referred to as the observable universe. Assuming that the cosmos is isotropic and homogeneous, that is, that it always presents itself the same to the observer regardless of location or direction of observation, a spherical space arises around our home planet that defines our cosmic field of vision. Interestingly, however, every point in space has its own observable universe, which may overlap with others. But how far into the cosmos can we really see? Basically, the observation horizon, our colloquial view limit, is defined by the information that could have reached us since the Big Bang. And given that the birth of the universe occurred about 13.8 billion years ago, one might assume the distance to the observation horizon is 13.8 billion light-years. But that's not true. In reality, the corresponding value is approximately 46.3 billion light-years. This is because the universe is not a rigid, unchanging construct, it has been expanding relentlessly since its creation. However, the cosmos is not expanding into an existing space, rather, the space itself is continuously growing. Accordingly, the structures that now mark the boundary of the event horizon were only 40 million light-years from Earth when they emitted their light. In other words, this means nothing more than that the distances already covered have been retrospectively extended due to cosmic expansion. At the same time, however, this also means that exploring such remote areas is always tantamount to cosmic time travel. Since the corresponding objects have long since crossed the event horizon, it's impossible to say what processes are currently taking place there. Is there an invisible giant slumbering out there? Given this situation, one might think that any attempt to answer the question of what lies beyond the observable universe is doomed to failure from the outset. And yet, some experts believe they have solved this fundamental mystery, despite all observational horizons and natural limits of visibility. More precisely, a few years ago, researchers became aware of a very strange phenomenon that stands in stark contradiction to our current models. But let's start at the beginning. According to established assumptions in cosmology, the proper motions of galaxy clusters relative to the background radiation should be randomly distributed in all directions. Just to recap, the background radiation, more precisely, the cosmic microwave background radiation, CMB, is a relic from the period shortly after the Big Bang. It still fills the entire universe today. Between 2001 and 2010, NASA's WMAP probe was dedicated to checking this very relic of radiation for irregularities. In doing so, it detected an extremely peculiar pattern that shouldn't actually exist. When the NASA working group led by Alexander Kashlinsky analyzed the WMAP data in 2008, they did not find random motion of galaxy clusters, but rather an amazingly uniform flow. And that wasn't all. It seemed the speed of this galactic flow also increased with distance. Ultimately, however, such a coherent pattern of movement can only have been set in motion by an extreme force of attraction. But which one? Well, that's precisely the question. And unfortunately, it cannot be answered with conclusive certainty. After all, these galaxy clusters appear to have fallen into the gravitational grasp of a structure that lies outside the observable universe. Henceforth, the phenomenon was christened the darkflow. The phenomenon made astronomical headlines again 2 years later when experts realized that not just 700, but now 1,400 galaxy clusters were participating in this peculiar mass migration. Although the direction of movement in the 4 observed segments showed some differences, the bottom line was that all areas revealed a clear correlation. In essence, the research world was enriched by two things: on one hand, by the knowledge that something colossal with a gigantic gravitational pull could be lurking outside the observable universe. On the other hand, by a nagging mystery. While Kashlinsky is in no doubt that the matter inside the observable universe cannot explain the flow of galaxies, we still don't know what is truly responsible for it. The NASA astronomer from the Goddard Space Flight Center was quoted as saying, "We don't have enough information to see what it is or narrow it down. The only thing we can say with certainty is that somewhere far away, the world is very different from what we see locally. Whether it's a different universe or a different space-time continuum, we don't know." So why is the dark flow theory so heavily criticized? Well, as mysterious as it is, the theory has its skeptics. Could it really be that in the invisible reaches of space there slumbers an immense accumulation of energy and matter that hopelessly exceeds the dimensions we know? Or is it perhaps even the result of bizarre space-time distortions that lead straight to a neighboring universe? The skeptical camp answers these questions with a firm no, for one simple reason: something like dark flow should not exist at all. According to them, the researchers around Kashlinsky made some serious methodological errors. A follow-up study concluded that the dark flow did not represent any physical phenomenon at all. In the original analysis, the directional dependence, anisotropy, of the cosmic background radiation was not adequately accounted for. Additionally, observations of more than 550 supernovae did not show a uniform motion pattern, but rather behavior that aligns well with our standard cosmological models. And then there's data from the ESA's Planck satellite, which also found no evidence of this inexplicable dark flow. So, is the theory still tenable, or can we confidently file it away as a misinterpretation? Well, that depends on who you ask. As far as Kashlinsky is concerned, it's indisputable that the dark flow has not been definitively refuted. He passionately points out that the observations are based on more than 1,000 galaxy clusters, measured up to a distance of 3 billion light-years. In view of this, it's hard to believe it's just a statistical coincidence. So what really lies beyond the observable universe? If we assume for a moment that Kashlinsky is right, then a simple yet thrilling conclusion follows: there must actually be something beyond the edge. Of course, this question has fascinated scientists and thinkers for generations. While dealing with this topic inevitably involves a detour into speculation, the theoretical approaches are nonetheless exciting, and sometimes quite unorthodox. The first theory is the simplest, that the invisible universe is structured in the same way as the observable one. But if we apply this scenario to an infinite cosmos, we are suddenly faced with a world where every possible thing exists. And by every, we really mean every. This includes, for example, a twin of the solar system, complete with an Earth identical to our own, except that you may have had cereal for breakfast there instead of toast. Or maybe in another version, you skipped breakfast. Or in yet another, you got out of bed to rob a bank. Some researchers even estimate that there exists an observable universe that is completely identical to ours. In other words, in the infinite depths of the cosmos, there may be a version of you that mirrors your every action. At first, this notion may seem to go beyond our imagination. But on second thought, it reminds us of what infinity really means, because by definition, it allows for an infinite number of possibilities. Thanks for watching Space Lab, your gateway to the unknown.